Good day, guys, and welcome back. Okay, today, as usual, we try to solve the question from my student here on qualitative analysis. What we have here is that we are given this green solid A. Upon reacting with dilute acid B, produces this blue solution C and gas D. The blue solution C, upon reacting with aqueous ammonia, this is to test for your presence of cation. Yeah. So the blue PPTE will be produced, and this blue PPT, the same blue PPT, if you react this with dilute sulfuric acid, this blue PPT will dissolve in this acid to produce a blue solution C. And the gas D, what we have here, upon bubble through aqueous calcium hydroxide, this is your lime water, all right, produces a white PPT. Obviously, your gas D is your carbon dioxide, no doubt about it. This is confirmed, right? Okay, so we look at this green solid A. Some students get confused. You know why? Because most students confuse this because they thought that this green solid must be Fe2 plus. Well, Fe2 plus, yes, of course, this is a green PPT, right? Is the color of the PPT when a substance that has Fe2 plus, right, reacts with aqueous ammonia or aqueous sodium hydroxide. However, the diagram indicates a green solid A before it reacts with anything else, right? Hence, A cannot be your iron 2 plus, yeah? Please take note of that, yeah? And but just the color, right? The color itself tell us that most likely this will be your copper carbonate, especially when I see the blue solution there, right? You know why? Because your copper carbonate, right, unlike most copper compounds, right, copper carbonate is green. And the other one that is not blue, another compound, the copper compound that is not blue, is your copper oxide. Copper oxide is black. So these two compounds of copper 2, they need not be blue, right? So obviously A cannot be your copper oxide because we were told that it's green, so this one out. So we keep in mind, right, that it may be copper carbonate. Later we check through these experiments that we have here. Well, some students may also be confused and argue that, well, so copper cannot react with acid based on the reactivity series. So yes, you look at your reactivity series, poso, mal, zil, H, cum, right? Your H is your acid. Anything to the left here, it will react with the acid. But copper, mercury, gold, platinum, obviously they do not react with acid. So how? Well, basically you know that we were given green solid A, not copper, yeah, not copper metal as an element, right? But a compound of copper 2 plus, yeah. So copper 2 plus, copper carbonate, do react. They can react with this dilute acid, no harm at all, right? Hence, A is a green compound which we need to find out more in detail. We check it out. Okay, and of course, upon reacting with dilute acid, it produces a blue solution C, and again react with aqueous ammonia, right? So most likely your this blue solution C must contain copper, right? Especially, you know what, when your copper, this blue solution C here, which contains copper, right? Because react with aqueous ammonia, you get a blue PPT. This is confirmation. Confirm copper 2 plus must be present. You cannot deny that. Okay, and obviously copper 2 plus must come from, it must be from your green solid A. It means copper must be there. All right. Okay. This copper cannot come from this acid. There's no such thing as copper acid. No. All right. So yeah, then what we have is that okay. So the green solid must be your copper, and then we look at this copper reacts with aqueous ammonia, turns it into blue PPTE, right? Aqueous ammonia, right? So that means your E must be copper what? Copper hydroxide, right? Copper hydroxide, OH, bracket 2. Why? There's copper come from this blue solution, C, and the OH must come from the aqueous ammonia, right? Aqueous ammonia is NH3, right? AQ. So aqueous means what? Dissolve in water. So dissolve in water, lots of water to produce your OH there, right? Okay. So and then the E react with sulfuric acid to get back your solution C. That means obviously, yeah, copper. This one must be copper sulfate because the sulfate must come from the sulfuric acid. Correct? Yeah. You see, um, you cannot just get sulfate from out of the blue, right? It must be from somewhere. The only way it can come is from the sulfuric acid. Yep. We look at this. You see, the equation hopefully will help you more. We have E react with your H2SO4 sulfuric acid, must be AQ. Obviously, you get your copper sulfate SO4, right? This is your C because the colorless, I mean the blue solution, C, right? And of course plus water, right? You check out, you say E, we check out is copper hydroxide, OH, right? Bracket 2. This is a solid, obviously, because it's a PBT, right? This is your blue PBT, okay? PBT, that means it's a solid, obviously, plus your sulfuric acid, H2SO4, okay? H2SO4 equals, sulfuric acid, right? Must be equal state, right? And it will produce your copper sulfate, right? Nothing else can be produced, right? Copper sulfate plus your, well, OH and H. What else? Water, right? This is your salt, okay? This is your water, right? And this is your basically your blue solution, yeah? Blue solution, right? That's why it's aqueous state, right? It's aqueous state. Water will be liquid, and if we want to balance up, okay, let's try to balance up. Well, basically we look at this, your copper 1, sulfate 1, hydrogen, this is 2 plus 2, 4, so we have to put 2 here to balance up, so total 4, and then 2 times 1 is 2, oxygen 2, then they'll balance, yeah? Okay, so you get the idea, right? That this is your blue solution C, okay? So blue solution C confirmed to be copper sulfate, and when we look at downwards, it means your copper sulfate react with aqueous ammonia to produce your copper hydroxide. Where in the world did sulfate come from in the first place? Before the reaction here, before the red arrow, right? Now, so this sulfate must come from your acid, right? In other words, your acid here must be your your sulfuric acid, right? It has to be sulfuric acid. Okay, that will be your sulfuric acid, H2SO4, right? Aqueous form. Okay, all right. So since we have concluded that the blue solution C is copper sulfate and the sulfate ions must be from the acid B, right? Given that gas D, we have concluded that it will be carbon dioxide, right? Bubble through your lime water here, right? Your PPT must be your calcium carbonate, right? Your solid state here. Where in the world did carbonate come from? The carbonate must be, we trace upwards, we go up, right? We go up because we go up here, and then obviously you know that this one is acid, so it cannot be carbonic acid, all right? Obviously not. It has to be, the carbonate come from your A. Cool, isn't it? Yeah, you cannot deny that. right? So your D, right, is carbon dioxide. Your F, yeah, your white PPT here is your calcium carbonate. Okay, right? Your calcium from your lime water, your calcium hydroxide. Okay, your carbonate must be from your solid green solid A, correct? Okay, your Fe is from your CaOH, right? CaOH. Your carbonate must come from your green solid A. That means your solid A must be your copper carbonate, CuCO3. All right. Well, basically, if I want to write the chemical equation, Ca calcium hydroxide, yeah, your lime water, right, react with your carbon dioxide gas, okay, will produce your calcium carbonate, right? Calcium carbonate. This is your white PPT. White PPT must be solid. This is your white PPT. Okay, that is your white PPT. Your white PPTF for as far as our diagram is concerned. And what else will be produced? You have OH. Yeah, so obviously your water will also be produced, right? And can we check it is balanced or not? Calcium is calcium 1, then after that your carbon 1, your oxygen 3 plus one more oxygen, so there are 4 oxygen here. So oxygen 2 plus another 2, so 4 oxygen. Hydrogen is 2, hydrogen is 2. Okay, done deal. It's balanced, right? Now, let's write down the basic idea of what we have here. We know that just now we are talking about the green solid A plus the acid B, right? Which will produce your C, your blue solution C, yeah? Your blue solution C plus your carbon dioxide D, right? In chemical equation, okay, let's write the chemical equations. A is copper carbonate, right? CuCO3, okay, in solid. Okay, I think it's better that I put this in green. You know why? Because that will be very friendly for my brain. I will be able to remember that copper carbonate is green solid. All right, and of course my acid, I love to put my acid as in red because my acid with what do you call it, litmus paper. Whatever litmus paper you give me red, it will turn red. It will still it will still be red. Blue litmus paper will always be turn red. So I love to put my acid as in red. Okay, and of course don't forget to put aqueous state, right? Because aqueous means dissolve in water, complete ionization for strong acid, right? And of course it will produce your this copper sulfate. Copper sulfate, yes, copper sulfate is compound of copper, and they are lovely, they are very friendly, they are aqueous. Okay, they are soluble, right? This is your what do you call it just now, the blue solution, right? Yeah, very typical of copper, except copper carbonate, which is not that friendly. Copper oxide in black, right? Copper oxide is black, right? Okay, and what else can be produced? You know that, let me just erase this one. Do not want to get confused with all these arrows. Too many. Copper carbonate will be there. Yeah, copper and carbonate. I mean, copper sulfate. Sorry, copper sulfate. And then we have carbonate and hydrogen. Carbonate and hydrogen. What can we get from there? We can get water, H2O, right? We have hydrogen. We have oxygen. Confirm water will be produced. And the next one is your we have carbonate, right? Confirm we have your carbon dioxide. Done deal. And of course this one is a liquid state, this one is a gaseous state, right? That's all, folks. That's all. Okay, thank you very much for watching. Have a nice day. Take care. Bye bye.